So the next lesson is on simple and compound interest. So we've talked about the exponent laws and exponential relations. What we're going to look at now is how do we apply exponential relations to financial math. So mainly borrowing and investing. And one of the things that we have to consider is that the interest in an investment will grow exponentially if it is a compounded investment. But we also have investments and loans that are calculated using what we call simple interest. So I'll teach simple interest first, which is not exponentially related, and then we'll teach compounded interest, which is related to the exponentials, and we'll show you the difference between them. So with simple interest, we basically determine it by finding the product of the principal. The principal is the amount that you invest, the interest rate, which is how much money you get per year for simple interest, and the time of the investment in years. This works the same for loans. So for a loan at simple interest, it's the interest that's owed is the principal times the rate times the time in years. So let's look at a question here. It says, calculate how much simple interest will be earned for an investment of $3,500 if it's invested at 5% for 6 years. And we simply just multiply those three numbers together. We get $1,050. So we owe the, we would, actually in this case it's an investment, so we would gain the $1,050, but we would also still have that $3,500. So altogether, our investment after 6 years is going to be worth $4,550. Let's look at a situation here where we have an investment that's taking place over a term that does not equally divide by a year. So in this case, 300 days. So example 2 says we have an $8,000 investment and we invest it for 300 days at 1.8%. So in order to represent our 300, we need to write that in years. So 300 divided by 365 gives us the number of years that 300 days would be equal to. So it's this ratio here, 0.821917. But we don't round that number. We don't divide 300 by 365 and then use a rounded number. We use the exact value. So what I write down here in my calculation is 8,000 times the rate, 0.018, times bracket 300 divided by 365. So that way we get the exact value. When I hit the equals button, I get 118.36. And the question here says determine the value of this investment after 300 days. So not just the interest. So then we have to add in the $8,000. And because we're dealing with money, we have to be accurate to the nearest penny. So the 100th digit is pennies. So we would round this 5 up because there's a 6 before it. So we would end up with 8,118 and 36 cents. Now we'll look at compound interest. So with compound interest, this is when we involve exponential relations. And we're going to have to talk about a little bit of terminology first. There's the compounding term is how often this interest is compounded. And what compounded basically means is when we recalculate the interest. And when we're compounding, we're actually recalculating the interest using the principal and the interest gained over the past term. So if we have an annually compounded loan or investment, that means every year we recompound the interest and we end up with a new value that includes the interest earned on the original principal plus the interest earned on the interest over the past year. So the other types of compounding terms, these are the ones you'll need to know for this course, but You won't be using all of them that often, so some are kind of more important than others. There are other compounding terms as well that we're not going to get into, so you don't need to know those. But we have annually, which is one compounding period per year. Semi-annually, which is twice per year, or every 6 months. Quarterly, every 3 months, or 4 times per year. Monthly is 12 times per year. Semi-monthly is 24 times per year. Bi-weekly, so this would be every second week, would be 26 times per year. Notice the difference between bi-weekly and semi-monthly. Semi-monthly usually occurs on the 15th and the 30th of the month, whereas bi-weekly usually occurs on every second Monday, for example, or a day of the week. Then we have weekly, which is 52 times per year, and daily, which is 365 times per year. We don't include a leap day in that. And the compound interest formula is A equals P times 1 plus I to the power of N. A is the amount of the investment. P is the principal. I is the compounded interest rate. N is the number of compounding periods. So because I is the compounded interest rate, we actually have to take whatever the interest rate they give us is and divide it by that compounding rate. And because N is the number of compounding periods, if you're given your time in years, you have to multiply that by your time in, you have to multiply it by the number of compounding periods per year in order to get that N in the correct compounding period. So if it's monthly, your N is in months. If it's daily, your N has to be in days. So there's another version of this equation that I like to use. It's slightly different. It's just that we add in the effect of our compounding rate. So we can give that a variable of x. So here we have A equals P, 1 plus I over x to the power of x times n. And x is that compounding rate. So how many times does it get compounded? So the table here shows you what those x values would be. So for annually it would be 1, semi-annually it would be 2, quarterly it would be 4, and so on and so forth. So we'll do an example of an annual compounded question, and then we'll do an example with compounding where it's not annual, it's at monthly or weekly or some other compounding period. Question 3 here says that we have a $5,000 loan. It's 6.8% interest compounded yearly. So to do this question, we write our principal. We multiply that by 1 plus our rate 0.068. That's annually. And then we raise that to the power of the number of the years, which is 5. So how much we would owe back after 5 years would be 6,947.46. We round it down at the nearest penny. The next question is a monthly compounded question. So let's say we have 18,000. It's compounded monthly, so I write in 1 plus 0.035. Then I have to divide by my x for monthly. And for monthly compounding, the x would be 12, so I divide this by 12. I raise this to the power of the number of years, 2.5, times my x, which is 12. And I end up with $19,643.46. The last question here, it says we have a debtor has to pay $2,500, and this debt is 80 weeks old. He's being charged interest at 5% compounded weekly. So let's take that principal, multiply that by 1 plus 0.05 divided by 52, because that's what we have as an x for weekly. But because we're given a value of 80 in terms of the time, not in years, we can just use that 80 for our n value. So here we end up with I have 2,699 and 80 cents. So I'll have to check. Maybe there might be a question. There may be something wrong with this question here. Oh, you know what? I just realized. So I did it a bit wrong. So let's look at this again. I was doing it a bit fast here. It says that the debtor has to pay $2,500 in order to pay back a debt that's 80 weeks old. So it was $2,500. We don't know what the principal was. We have to find out how much he originally loaned. So I have to divide that by 1 plus 0.05 divided by 52 to the power of 80. And, oops, I screwed that up. 2,500 divided by 1 plus 0.05 divided by 52. Close the bracket to the power of 80. And we end up with $2,314.99. Or, because we're asked to round to the nearest dollar, $2,315 was borrowed. Let's look at some of these other questions here. So for these support questions, you'll see a few types. I'll do one of each. So we'll do 1C. This is just simple interest. So it says we have $10,000 and we're investing it at 0.0615 for 12 years. And we're asked to determine the interest, and the interest is just $7,380. Whereas number 2, let's look at 2C. We're given the interest, $1,664. We're given the principal and the rate. We have to find out the length of the investment or the term. So in this case, we start with the interest, divide it by the P and the R, and we're left with the term, which in this case would be 8 years. Let's look at 3C. $125,000 is borrowed at 2.69%. So 1 plus 0.0269 compounded monthly for 25 years. So I have to do 25 times 12 for my N. So that $125,000 that was borrowed, if we wait 25 years to pay it back at that interest rate, compounded monthly, it almost doubles. And then for 4, we'll do 4C. It says after 8 years, an amount invested 5% compounded semi-annually has grown to $16,775, and we're asked to determine what the principal is. So here we start with the amount it has grown to, and we divide it by our 1 plus 0.05, and this is semi-annually, so divided by 2 to the power of 2 times 8. We end up with the original amount invested was $11,306. So looking at, let me just add my other screen here, window capture. So let's look at what this quiz will look like for this problem. This lesson, rather. So for our simple and compound interest quiz, you'll have questions just like this here, and the units is always going to be dollars, so just put dollar in for units. Then let me move this screen here a bit so we can see our calculator, and then you'll add in your answer. So this is 8,500 is borrowed for 12 years at 0.063 compounded annually. Sorry, I was doing this. I thought it was a simple interest question. So we'll do 8,500 times 1 plus 0.063 compounded annually. So close that to the power of the 12. So this is how much the value would, or the investment would be worth. To find the interest owed, we have to subtract the 8,000. So it looks like we have 963. Let me get that number again. Sorry, 9693.68. 9693.68. So that's how you'd enter your answer with dollars here. This question, determine the interest earned. If we have $7,400 invested at simple interest for 6 years, so we just write in $1,554. Don't need to put the 00 for the cents. The next question, it's $81,000 at simple interest, but it's at 61 months, so we have to do 61 divided by 12. So the interest would be 22646.25. And we put dollars. Now let's go on some of the more difficult questions. I'll do the last one. It says determine the principal if an investment is worth $5,500 after being invested for 2 years, compounded monthly. So this value, 5500, divided by the 1 plus 0.045 divided by 12 to the power of 24, because that's 2 times 12. So my value here would be it was $5,000 originally. $5,027.47. So that's how you'd be answering these problems. If you have any questions before you take the quiz, please ask them to me, and I will be glad to help you out.